Will scientists searching for signs of life elsewhere in the solar system live to regret their decision recently to send NASA to Saturn's moon Enceladus instead of Jupiter's moon Europa? Both moons are known to have saltwater oceans under their thick icy surfaces, and both appear have geysers that send some of that water, as vapor, into space. The recent Decadal Survey for Planetary Science and Astrobiology decided that the plumes at Enceladus were more reliable and easier to sample than those at Europa, so overlooked the $5.8 billion Europa Lander mission in favor of the $4.9 billion Enceladus Orbilander. Now it looks like Europa may have an abundance of water pockets just beneath its icy shell, and possibly oxygen in its ocean. Published in Nature Communications, a new study used ice-penetrating radar in Greenland. They did so because they noticed that ridges on the icy moon looked extremely similar to a minor feature on the surface of the Greenland ice sheet, which they had already studied in detail. It suggests that Europa's ice shell may not be a barrier to exploration, but actually a more dynamic place that could itself be habitable. Because it's closer to the surface, where you get interesting chemicals from space, from other moons and from the volcanoes of another moon of Jupiter called Io. If the mechanism we see in Greenland is how these things happen on Europa, it suggests there's water everywhere. The researchers were actually working on climate change science when they noticed that an in-shaped crest in Greenland could be a miniature version of an obvious feature on Europa. You can see them in any image of Europa, such as this one, below, as dramatic gashes across the icy surface. They reach nearly 1,000 feet and are separated by valleys about a half-mile wide. The above image is actually from NASA's Galileo orbiter, which was the first spacecraft to spot the features on Europa in the 1990s. The next major close-up that scientists will get of Europa will be from Juno. In late September 2022 it will get to just 221 miles/355 kilometers, above Europa's surface. In Greenland, this double ridge formed in a place where water from surface lakes and streams frequently drains into the near surface and refreezes, said Riley Culberg, lead study author and a PhD student. One way that similar shallow water pockets could form on Europa might be through water from the subsurface ocean being forced up into the ice shell through fractures, and that would suggest there could be a reasonable amount of exchange happening inside of the ice shell. It's long been thought that,